All right. We told you a story. I got to try to remember what I was telling somebody earlier who asked me this question. All right. So would it be unusual to find a dude, go out and randomly select a dude, and the dude is 70 inches tall exactly? Would that be unusual? Would you freak out if you saw that? 70 inches is 5'10". Would you be like, holy crap, I've got to take a picture of you. You should be in the news. Would you do that? Would that be unusual? No, of course not. That would not be unusual. But it would be unlikely to find a dude who was exactly, and I mean 70.0000000, good God, inches tall. I really want you to think about that. Think about that. That's the difference between unlikely and unusual. Unlikely means the probability that that specific thing happens is low. Unusual means that whatever it is that you're looking at happens in an area where very few things happen, right? So I could have a normal distribution. If I toss a coin, flip a coin, there's a good verb. If I flip a coin 1,000 times, it's actually the same example the book gives for this difference. And this example I like. If I flip 1,000 times, then the distribution would look something like, really spread out. And this is the most likely thing. If I flip a coin 1,000 times, what's the most likely number of heads that I would see? 500. But that probability would actually be below 5%. Because how many things could happen? 1,000, right? So therefore, there's very little probability left. You've got to put all this probability all the way out here. So this exactly happening, getting exactly 500 heads, would freak me out. Once you get past the fact that I'm flipping a freaking coin 1,000 times, what would freak me out is I get exactly 500. That would freak me out. That's some of our intuition. It's unlikely to get exactly 500 heads. That is unlikely. But it's not unusual, right? It's not unusual. Sorry. Because that is in an area where a lot of things happen. Unusual will be out here, right? Do I ever go out there very much? No. Normally I'm in here. So that's why anything in here, in between -2 and 2 right now, later we're going to move that a little bit, but it's the same idea. Anything in there is not unusual. Because that's where most of the stuff is. But any specific event could be really... In fact, anything that happens, I throw this. It ended up right there. Holy shit! The probability that it would end up right where it did is so freaking low. But every day, every second, something happens that was really, really unlikely, but not unusual. Otherwise, we would eternally be going, whoa, holy shit, my foot, I put it right there. I'm being silly, but do you guys see the difference? A specific thing happening is almost always going to be unlikely. That's the weirdness about how we live. But it's not unusual if it happens where most of the things are. It's only unusual if it happens in an area where there's not much. Right? So somebody being exactly, I don't know if you guys really get this. If I weighed a dude, and it came out to be exactly 210.00007444444444444 pounds, that would be unlikely. Go randomly select somebody and have that happen. How many people would you have to go randomly select, do you think? You're going to get it on the third person? No, you're never going to find that person. So if you do find that person, in one sense you'd be like, whoa. But in another sense you wouldn't. Obviously, thank God we live in the other sense. Because otherwise, like I said, we'd be eternally going, whoa. Right? So the 210 pounds for a dude, for like a 6-foot tall dude, is not a weird weight. It's not unusual, but it would be unlikely to find that exact weight. Or maybe. And that's the point of that problem. Right now we can't calculate the probability. So in one sense I don't like that problem right now. But I wanted to force you to read that part of the section about unlikely versus unusual. they do a decent job of explaining it. It's actually the same way I've almost always explained it.
So is it not unlikely then?
205 girls is unlikely. It's unlikely. Just because the probability of exactly that is less than 5%. But see, that's the unfair thing about this problem. We can't currently calculate that. It's a little unfair. But it certainly is not unusual. Unusual would be far away from the middle, far away from 200. Yeah. Cool. Chapter 5, we'll finally actually be able to come back and calculate probabilities for that. So if I remember that, we'll do that. We'll calculate probabilities for flipping a coin 1,000 times so we don't actually have to do it. That would be nice. Theoretical stuff has its advantages. So anything else from homework? Yes? Exactly. Right? And of course I'm not talking about reducing or something, but from the initial place, it will always be that total denominator, that total number, unless I tell you more information. Because then you can eliminate certain possibilities, right? Good. So if I don't say given, if I just say probably this and that, you don't know that either of those things happen. It's the probability that and that happens. So the bottom is still everybody. Good. Cool. So remind me, what's happening a week from today? The double quiz. So I got the practice quiz today. I'll give that out towards the end of class. And I'll have an answer key for it on Monday. Is there anything else from homework? Yes?
Can you give an example of unusual?
Oh, yeah. Go out and find a 7'11" dude. See, and that's unusual because his height is so far away from the area, the range of heights that I would be expecting. You kind of with me? It's not because exactly 7'11" is it's because 7'11" is in an area that I normally don't see anybody. So that's the whole in between two standard deviations, right? -2 to 2. So that middle part is the middle chunk where most of the stuff is. To be unusual, you have to get outside of there. I like it.
So if you found him, would it be unlikely?
It would, yeah, definitely. Anything out. Let me draw this. So I really want this understood. Let me see if I can. Let me just try to say this and see what you guys. Theoretically, a single instance has a probability of 0 because it doesn't have any area to it. It's just a line. We know that's not true. This dude has some probability to happen, right? So things in here would not be unusual, but they could be unlikely if they have a less than 5% chance. That's what unlikely means. Anything out here is automatically unlikely, basically. Right? Anything out there is automatically unlikely because any single thing has got a less than 5% chance of happening. You guys kind of with me? Because if this is if this is a normal curve, and here's my usual range, right? Here it is, -2 to 2. So what's in here? How much is in there? What percentage of the data is in there? 95. So what percentage of the data is out here?
5.
So if all this combined is 5%, any single thing out there will certainly have less than a 5% chance of happening. So it's automatically also unlikely. This stuff is not unusual, but it could be unlikely. All right. In fact, theoretically, any single instance of something happening is remarkably unlikely. It's just not unusual most of the time, right? That's a weird thing to really think about. It's kind of neat to me. And that sort of relates to physics in a way, because any single thing that happens, there were so many other things that could have happened, that if something happens, it's almost like eternally weird. Right? You just yawned. I'm going to make a big deal out of it. That's so weird. But I mean, people yawn in math classes. I'm used to it. I don't take it personal anymore. When I first started, I'm like, oh, shit. But now I'm like, yeah, well. Sorry, I had to call you out. So anything else from homework? Okay, all right. So let's finish up chapter 4. the two main definition kind of stuff that I want to talk about was the disjoint, which I still am going to call by its older name mutually exclusive. So if I say this, it's because that's what it really is. At some point they changed the word to disjoint, right? Which my mind automatically goes disjoint, that joint, I don't know. Mutually exclusive actually makes more sense. They mutually exclude each other. Right? So to be disjoint, if you're one thing, you can't be the other one. So visually, it would look like this. Right? And I used to say cats and dogs, and then there was some stupid cartoon where there's a cat dog, and it's like shit. And then I said men and women, and of course some people are transitioning and maybe getting their own show. The only reason I know that is because I watch The Soup. Right? That's all I watch. That's how I keep up with all the other shit. So I say, what did I say earlier? A human and an igneous rock. So I defy you to find an igneous rock that is also human. Bring him in if you find him. Or her, I don't know. Or whatever gender they have. So when you hit these kind of problems in the homework, you just think to yourself, could anybody or anything be in one and the other, or do one and do the other? So like if event A was a student at community college, and event B was a person in debt, is that disjoint or not disjoint? Meaning, would that look like this? Hell no, because people that are students at community college could very easily be in debt. In fact, I could just make this people, because some teachers at community colleges could very easily be in debt. You with me? So that's what you think. You think, could there be a person, because this is people in this case, could there be a person that's this and this? If there can be, then it's not disjoint. This is not disjoint. Not, S in there, John. Not mutually exclusive. They don't mutually exclude each other. They actually include each other. Do you get that? All right, good. Okay, so it's not that bad. Yeah.
Why don't you say joint?
Say
Why
again?
don't you say joint instead of not?
Because joint actually doesn't make much sense by itself. That's why. And remember, what do I like? I like this word. Mutually exclusive. Right? Or not mutually exclusive. Makes more sense. But I agree with you. The word dis is what's making that already negative. So this is like a double negative. Well, it's too damn bad for you. The stats book said, I don't care about grammar. Right? So it's disjoint or it's not disjoint.
Good together.
Let me see. Let me give you a couple problems real quick out of the actual homework section. Randomly selecting somebody and getting someone who believes in UFOs is event A. Randomly selecting somebody and getting someone who believes in the devil is group B. Is that disjoint or not disjoint? Yeah, because the person could believe that the devil's actually flying the damn UFO. Who knows, right? There's probably been cults that have actually believed that. I don't know. Let me try to find one. Let's see. Oh, this one's kind of evil. Selecting a drug screening result and getting one that's a false positive. What does false positive mean? In this case, it's a drug screening and you get a false positive. That means that the test thinks that you use drugs when in actuality you don't, right? So that's part one. Randomly selecting somebody and getting a result that was a false positive. Randomly selecting a result and getting one from someone who uses drugs. Are those disjoint or not? They are totally disjoint. Can you get a false positive? Meaning what? Meaning you don't use drugs and use drugs at the same time. That would be pretty powerful drugs. You use so many drugs that you actually don't use drugs at the same time because you've gone to that level, right? I am this and not this. You annihilate yourself. I don't know. That was kind of an evil one because you got to really understand what false positive means. But then you break it down to, can somebody use drugs and not know? That's totally disjoint. You're one or the other, right? You can't go, well, it's only on Saturdays. No, then you use drugs. Yeah. Oh, this is section 4.3, page 153. Let's see. Most of these. Oh, and then the first one's kind of silly. Arriving late for your next class, arriving early for your next class. Yeah, they start you off really easy. Those are disjoint, totally. You can't do both. Unless, of course, you're on those aforementioned drugs. I don't know. Did I just get here before me? Yeah, you did. It's freaking us all out. All right, so let that be simple. Now here's the one that's a little bit harder to get. The idea of independence. Of course, all I can think about is that Independence Day 2 is coming out. Or, they're going to start making it. I don't think so. They got Thor and they got Jeff Goldblum, right? What's his name? Liam? The Thor dude. So I don't know. I don't know if Will's going to be in there or not. You'll probably try to get his son in there just to keep that going. What's up? Oh, well, maybe that won't happen then. All right, so here's the idea of independence. If let me give you a nice example of this. So let's go back to cards again, just because it makes it easy. So what's the probability I pick a king out of a deck of cards? Pick one card. 450. All right. What's the probability I get a king given it's a club? So I got a deck of cards and I pick one and I tell you I just picked a club. What's the probability that it's a king? Yeah, so what's going to be on the bottom is how many clubs there are, right? And there are 13 of each suit. So there's 13 clubs. And how many kings in those clubs are there? One. There's only one king of clubs. Did the probability change? All right, so this is the heart of independence. This is what independence means. And if you think about it this way, it makes complete sense. Did the probability of king change because I knew it was a club? Did it change? No, it was 1/13th, and now it's 1/13th, so it didn't change. You with me? All right, please understand that. So king and clubs are independent events because one happening did not change the other one's chances of happening. That's what independent events means. So here's an example of dependent events. What's the probability of a king given it's a face card? How many face cards are there? There's Jack, Queen, King, 4 suits. There's a total of 12. Out of those 12 cards, how many are kings? 4, because all the faces are still in there. I didn't throw anybody out. So what's the probability now that it's a king? Did it change? It did change, right? From 1/13th to 1/3, the chances skyrocketed. So if I'm betting money and I'm like, I want it to be a king, and somehow I know it's a face card, and I'm like, oh good, my chances are now 1/3, right? 1 out of 3. So I got a better chance that it's going to be money for me. You guys follow? So what is it? What's the test then? What's the test? What am I comparing? So I'm comparing the probability of A given B. What am I comparing that in each of these cases? This is A given some other B here, right? But I'm comparing it against what Against what? What am I comparing? What did we compare this to? The probability of A. So if B happens and A doesn't give a shit, right? B happens. That happened. Did A care? No. It didn't change its probability of happening. The probability it was going to be a king is exactly the same. Nothing changed. You with me? So therefore, these would be independent. If A given B is the same as what A was, they are independent. If these two are at all different, they're dependent. All right, how are we doing there, Zach? I'm considering right now showing you the picture that always throws people off, and I think I won't, just because I don't want to be the one that throws you off. So if you just keep in mind that that's what independence means, that if something happens and the other guy doesn't care, his probability remains exactly the same, that makes sense. They're independent. If you're independent from somebody else and they do something, do you care? No. You're like, do whatever you want to do. I don't care about it. If you're dependent on them, you're like, what do you do? Right? Your probability of doing something changes because you're like, I was going to go with it. No, screw that. But if you're independent, you're like, oh, all right, then you just go somewhere else. You do what you're going to do. All right, maybe. Yes?
So in that example, if they only gave us probability of the kings giving club, they want to go back and find the probability of the king.
Normally the question will be something like, are events king and club independent? This would be the question, right? Are these events independent? Then you have to go calculate this and compare them. This is the test. This is the test for independence. That sounds like I'm teaching a history class or something. We might be independent. We have to take the test. All right. So that's what you do. If somebody or something or a test or a quiz or me asks you, are these two things independent? You calculate those two things. You cannot explain it to them. You can't say, well, a king could sometimes... No, you can't explain it to me. Don't write me a little thing. Don't write me a paragraph. Don't write me anything. Do the math. Only the numbers can save you here, right? If the numbers are the same, they're independent. If they're not, they're dependent. You can't explain it to me in a paragraph. Well, kings can be... No, screw that. No. All right. Cool. And that's pretty much closes the door on chapter 4. Yay! So anything left over from chapter 4 that you need to ask, because we're going to get into chapter 5 actually right now. Yes?
We're going to go, are we going to need to know 4.6 at all?
No. Well, the only reason I don't do 4.6 is there's got a lot of nifty stuff in there, but this is not a probability class. So that's why some of my colleagues do 4.6. All I do is when we need it, there's only one thing from 4.6 that we really need for stats. So I'm going to teach you that when it comes up. So 4.6 has got a lot of other stuff. It's all nifty as hell. But there's no time to include it. Yeah. Cool. But if you want to know about permutations and combinations and all kind of stuff, that's where they talk about it. Yeah. Okay. So what we're getting into now is, so what did I tell you about stats tables? Like x minus x bar, x minus x bar squared. What did I say about those? The nice thing. What's the nice thing about those? As long as you actually did them on your homework, you'll never have to do them again for me. Ever. Not even on the final. I'm never going to make you do those tables. Right? But what came out of that was every time we have data given to us in a different way, we want to figure out the mean and standard deviation somehow. Right? So I could be given data in a list, and that's chapter 3. Mean, standard deviation, I'd have to do chapter 3 stuff to it. You with me? I can be given data in different ways. So here's the other way I can be given data. Well, let's see. Well, let me do it like this. Let me do it the way I always do it. So I want to bridge between the old way and Chapter 5's way of doing things. Chapter 5 is really all about if there's repeats in my data. So for example, if my data looks like this. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, Jeff. So if my data look like this, how could you be smart about calculating the mean? So if I want to calculate the mean, how do I do that? What's the formula? The old formula from chapter 3. We're going to do it the old way, and then I'm going to show you the new way, how it comes off of this. Yeah, you add them up, divide by n. So you would get, what's a smart way to write this? Wouldn't this be 4 1s plus 3 2s plus 1 3 plus 2 4s? Now just stay with me. I'm showing you why the math works in chapter 5. Very few of us would probably do that. But I could if I wanted to, of course, right? Yeah, you could do whatever. Divided by 10. Now, off to the side, we would then actually do this, and we get 10, 13, 21 divided by 10 is 2.1. I did that right. But we're not going to do that. We're going to take a little bit of a detour. And this is where students kind of lose track. I'm just showing you why the math works in chapter 5, and then I'll show you why we need this new math, because this is a very simple example that we could do like chapter 3. But then you know they're going to get more disgusting, and I'd like to have chapter 5